Hello, future engineers. Good day. So for discussion, in this our topic for this discussion on the dynamics of rigid bodies, we'll tackle on the relative motion of particles using translating axis. So unsa man yung relative motion of particles using translating axis? If you remember our discussion before or prior, this topic is on the absolute dependent motion of two particles, diba? So katong absolute dependent motion of two particles, uh, we have two connected motions, or we have two particles, and then they are absolutely dependent. That when one, let's say for this one moves to the left, the other will also move to the left, or when this one moves to the right, the other will also move to the right. That is a absolute dependent motion. Now we have here two particles which are completely independent of each other's motion. So saan man ni siya? The concept of the relative motion of particles using translating axis is that we are trying to determine the motion of a particle like this one. We are trying to determine its motion which is relative or in relation to the motion of this particle. So as you can see here, we have a natay planes no on the left side in the drawing here. So unsa may purpose ani these four planes that were shown here as are let's say if we think of them as a particle, they are independent particle and they are moving also at the same time. Now, if you are the pilot of each of these if in one of these planes, you need to be you need to know or at least have some idea of your relative position with respect to the other plane. So for instance, you are the pilot of this plane. So dapat imong tansya, you have an idea of your relative position with this plane in your front. Aron in such a way that you cannot overspeed with this one, which will result in a collision. Or if you are the pilot of this plane, you should also be knowledgeable, or you should have an idea of your relative position with the other planes because just in case mo isbog ka na to or diri, you should have an idea on your speed in such a way that you cannot hinder or you cannot crash or collide with the other plane. So that is the concept of the relative motion of two moving particles. Now, in two moving particles, di ba last time, uh, we reference the particles on a in a fixed frames, on a fixed reference frame or a fixed reference axis. Now for this one, namagay times nga ang motion, it is difficult to describe from a fixed reference frame or an axis. Now with this one, as you can see here, no, we have the axis here. We have the x, the y, and the z axis. So the point here, these are represents the fixed reference frame. Now say there are two moving particles. We have particle B on this side. We also have a particle A on this side. Now, at times, Magoda, it's complex or it's already complicated to determine the path of the motion of a particle from a fixed reference frame. Di ba? For instance, nakay duha ka plane nga nakita naglupad. So, imong bato na is that imong reference frame, dili ka mo reference frame from the building to the plane to another plane to the second plane. You have a reference frame from each other of the two moving particles that we can see. So same ra gyapon na siya diri sa ato ang relative motion. So as we can see, we have RB is the position of here of the particle B, and RA represents the position of our particle A from the fixed or the absolute uh, reference frame, or we also call this the absolute position. And then, as you can see, we have here the RB over A. So, what does this represent? Now, if we try to determine the relative position of B with this one with respect to A, so we have a what we call the relative position vector or the relative position equation. So we can represent this in vector or in scalar. But first, let's write this in the vector form. So you have the absolute position of the B. So we can write the absolute position that is from the fixed reference frame is equal to the absolute position of the A plus the absolute position of, the relative position of B with respect to A. So that this one here is the relative position of B with respect to point A. So the for our point A here became the translating frame or the translating axis. So ato nang gibasihan niya or gihimo niya natong new reference frame here for the B is kaning particle A nato. Now this can also be written in the scalar form. We have the relative position at x of B and the relative position of A with respect to x is just equal to the RAX plus the RB, the relative position of B with respect to A on the X. Same also with on the Y. Now, if you take the first time derivative of the position, of course, the first time derivative of the position, so if you have a dr over dt, then you will have a velocity. So we have here a vector velocity of the B is just equal to the absolute vector velocity of the B is equal to the absolute vector velocity of the A plus the relative velocity of of particle B with respect to A. Same thing also that this can be written also in scalar notations. So here we have the vector and then here we have the scalar. Now if we try again to differentiate this with respect to time, the velocity, then we will have our acceleration. So we'll have our acceleration of the B, the vector acceleration of the B is equal to the vector acceleration of the A plus the vector acceleration of relative vector acceleration of B with respect to A. Now, what happens if babalik siya? With this one, we are trying to get the relative motion of particle B with respect to particle A. Now, what if we are trying to get the relative motion of A with respect to the motion of particle B? So, mabali na po ang equation. So, we will have the absolute position of the A is equal to the absolute position of the B plus the relative position of the A with respect to B. And then, so on and so forth with the velocity and the acceleration. Okay, so para mas masarap na natin, let's proceed with our first problem. We have here a train traveling at a constant speed of, we have a 60 miles per hour and crosses over a road as shown. If the automobile A is traveling at 45 miles per hour, we have here the 45 miles per hour along the road, determine the magnitude and the direction of the velocity of the train relative to the automobile. So, ito na yung sulat. We have the velocity of the train, which is equal to 60 miles per hour. We also have the velocity of the automobile, which is equal to 45 miles per hour. Then, we're asked to find what? We are asked to find the magnitude and direction of the velocity of the train relative to the automobile. So, are we using Vt sub Vt over A or Va over T? So, ingon man niya diri that the velocity of the train relative to the automobile. So, in this problem, we are to determine the relative motion of the train with respect to A. Therefore, we were asked to find is the velocity of the train relative to the or with respect to the automobile A. Okay, so here, let's just draw the motion. So you have a train crossing the road towards the right. We also have our automobile traveling in that direction. Now we are asked to find the relative velocity. So we have our particle T and particle A. Relative velocity of the train with respect to A. So we have our velocity of the train here equals to 60 miles per hour and the velocity of our automobile at 45 miles per hour. And the road of our automobile is inclined at 45 degrees. So we just follow the equation. We have the uh, vector velocity of the train. The absolute vector velocity of the train is equal to the absolute velocity of the automobile plus the relative velocity of the train with respect to the automobile. Now with the vector analysis. So first, let's try to solve with the vector analysis. So the train moves at the right at 60 miles per hour. So that is 60 I hat. The I hat denotes the direction of the magnitude near 60 miles per hour. That it means to the right. Since the train moves only to the right, therefore wala siya velocity towards the, let's say, towards the y-axis or towards the j hat is equal to the velocity of the A. Our velocity of the A is inclined, therefore it has a component along the I hat or the x-axis and then on the j hat or on the y-axis. So we'll have a 45 miles per hour cosine 45 I hat plus 45 sine 45 j hat plus the relative velocity of the train with respect to the automobile. So here you get that the relative velocity of the train with respect to the automobile is just equal to, we just transpose the other items on the other side. So here we have a 28.18 I hat minus 31.82 J hat. And then its unit is in miles per hour. Now we're asked to find the magnitude. So the magnitude of the relative motion of the train with the relative velocity of the train with respect to the automobile is just equal to the square of the relative motion of the train and the x and the square of the relative motion of the train with respect to automobile on the y component. So that is just square root of, we have the 28.18 squared plus the 31.82 squared. And finally, the magnitude of the velocity of the train with respect to the automobile is just equal to 42.5 miles per hour. This is the magnitude. How about the direction? So, yun niya. So, here we have a positive direction. So, if we have a 28.18 miles here, miles per hour, that is the x component of the relative motion. And then we have a negative 31.82, that is downward. And if you're using the parallelogram method, so this is the velocity of the train with respect to the automobile along x. and then the velocity of the train with respect to the automobile along y, then this will be the relative velocity of the train with respect to the automobile or as relative to the automobile. Now, what is the direction? Again, we are to get the direction is the this one that is measured from the horizontal or from the x-axis. So, dali na kayo. Our theta is just the tan inverse of 31.82 over 28.18. Or our theta or the direction is just simply 48.5 degrees. So that's it. Now, how about using the scalar analysis? So same concept you can applied now. And the scalar analysis, we just resolve them into components. So for the along the x, then we have the same VTS is equal to the velocity, absolute velocity of the automobile plus relative velocity of the train with respect to the automobile along x. Then we have here is 60 is equal to 45 cosine 45 plus the relative velocity of the train with respect to the automobile along the x, or simply that is still 28.18 miles per hour. Now along the y, so we don't have a y component of the velocity of the train. So that is 0 is equal to, you have a 45 sine 45 plus the relative velocity of the train with respect to the automobile along the y. So that is just equal to negative 31.882 miles per hour. Now, the magnitude of the velocity of the train with respect to the automobile is just equal to, same thing na gyapon. Just square those components, and then eventually you'll arrive at the same answer and at the same direction, which is equal to 48.5 degrees. See, the concept of the scalar analysis is that you just solve them separately, resolving the horizontal and the vertical direction of the component. Here, the negative symbol denotes that the velocity or that it moves downward, that the direction of this one is towards this one. Nagkalayo sila at nga na ang ilaang direction.